x to the power of what? 3 by 2 minus
Yes,
1.
sir. 3 by 2 minus. Yes, sir.
And you had a root x also here. I had taken root
Yes,
x
sir.
common. I had taken a root x common. Okay. And this is what you are getting.
Yes, sir.
Okay. And now when I was breaking this as what? A cube. Let me write this as square root x cube. Isn't it? This is what I had shown you that day.
Yes, sir.
Sir. Yes, sir.
And you multiply this. You get 3 by 15 cos to the power of 5x minus 5 by 15 cos cube x. So what you get here is root x into root x plus 1 into root x minus 1 into root x square. Okay. Root x a square plus ab plus b square, right?
Yes, sir.
And these would remain as it is, plus 1 by 5 cos to the power of 5 x minus 1 by 3 cos cube x. Okay, let's see. So you have this is equal to root x into root x plus 1 into root x minus 1 into x plus root x plus 1 divided by x root x plus x plus root x, and this would remain as it is, 1 by 5 cos to the power of 5x minus 1/3 cos cube x. Okay, now what you do is you multiply this root x with
Sir, 1 by 5, no? 1 by 5 cos to the power
1 by 5.
5x.
Yes,
You have
1 by
written 1 by 15, you have written, sir.
1 by. I think this was the only mistake I made that day. Anyway, so
Sir, 1 by 15.
yeah, this also becomes 1 by 5. Okay,
Yes, sir.
so now you multiply this root x with this expression, and these two you multiply to get root x square a square minus b square, isn't it? This is a plus b into a minus b, so which becomes a square minus b square. And if you multiply root x with this, what do you get? X root x plus root x into x is x plus root x divided by x root x plus x plus root x. So what happens? This and this cancels, and these two remain as it is, 1 by 5 cos to the power of 5x minus 1/3 cos cube x. So this is x minus 1 plus 1/5 cos to the power of 5x minus 1/3 cos cube x. Okay, so this is what we have got y. Now we are going to differentiate. We have simplified this. So therefore dy dx is ddx of x, or let's say first write everything here, x minus 1 plus 1/5 cos to the power of 5x minus 1/3 cos cube x. Now we differentiate ddxx minus ddx1 plus you take 1/5 out because it is a constant, ddx cos to the power of 5x minus 1/3 ddx cos cube. Okay, so now ddxx is 1, ddx1 is 0. And what about 1/5 ddx cos 5? First we differentiate power to get 5 cos to the power of 4x. Then into the differentiation of cos. Yes, right or wrong?
Yes, sir.
Now you differentiate the power 3 cos square x into the ddx of cos x. So what do you get? This 5 and this 5 cancels. This 3 and this 3 cancels. So what do you get? You get 1. Now, yes, 1 plus cos to the power of 4x. And what is ddx of cos x? It is minus sin x. Minus cos square x. And ddx cos x is minus sin x. So 1 minus cos to the power of 4x sin x minus or plus cos square x sin x. Now from these two, what can you take common from these two? You can take cos square x sin x common. And what are you left with? Here you only left with cos square x. Okay. And since you are introducing brackets, you have a plus sign here. So this will change to a minus sign. So 1 minus cos square x sin x. Now see, I've got a 1. Okay, let me write it in this way. 1 cos square x minus 1 can be written as minus of 1 minus cos square x, which is equal to 1 minus cos square x sin x into minus sin square x, which is 1 plus sin cube x cos square x. So have we got the answer or not? Have we got the answer? 1 plus dy dx is equal to dy dx is equal to um,
Plus sin cube x cos square x.
yes, we got dy dx is equal to this. Yes, we have got here. We have got here.
Yes, sir. Yes, sir.
Okay, so let us continue with differentiation by um, differentiation of implicit functions. Okay, so let us continue with differentiation of implicit functions. Um, exercise 6h. Exercise 6h. We start with a very simple problem. Okay, x square. Govinda, can you hear and can you see or not?
Yes.
Okay, x square plus y square is equal to a square. Yes, tell me. Okay, we will start with a very simple problem. X square plus y square is equal to a square. This is an implicit function. in x and y. In fact, you can convert it into an explicit function, but you will get plus or minus. Okay, better to keep it as an implicit function. You can differentiate as it is. So what I do is I write this as differentiating. In remember, whenever you are differentiating an implicit function, you will write this: differentiating both sides with respect to x. We get d dx x square plus y square is equal to d dx a square, right? That means now d dx
Yes,
of
sir.
x square plus d dx of y square is equal to a is a constant, so it will become 0. Now what is d dx
Yes,
of
sir.
x square? You see an x here, you see x square here. D dx of x square is clearly 2x.
Yeah, 2x.
Now how do I differentiate y with respect to x? I told you that day that if you want to differentiate y with respect to x, you first differentiate y with respect to y to get 2y. Okay,
Yes, sir.
and then you differentiate
Yes.
dx
dy by dx.
y dx
or you add dy dx. Okay, equal to 0. So that means 2x plus 2y dy dx
dx is equal
equal
to
to
0.
0. You can take 2 common, twice x plus y dy dx equal to 0. That means x plus y dy dx
Is equal to
equal to
0.
0. That means y dy dx is equal to minus x. That means dy dx is equal to minus x by
Yes, sir.
1. Understood?
Yes, sir.
So we move on to the next problem. It's a very simple problem to start with. Let's say this: y square equal to 4ax. Next one, find dy dx where y square is equal to 4ax. That is the question. Okay, so we see differentiating both sides with respect to x. We get d dx y square is equal to d dx 4ax. That means differentiating y with respect to x means first we differentiate y with respect to y, and then we differentiate y with
Yes,
respect
sir.
to x is equal to, now 4a is a constant, you can take out of the differentiation, 4a
Yes, sir.
d dx x. Okay,
Yes, sir.
and then what happens, you can
Yes, sir.
cancel this 2 with this 4. Okay, so you get y dy
Yes.
dx is equal to
Is
2a.
equal to 2a.
That means y is equal
Yes.
to sorry, dy dx is equal to 2a by y.
2a
That is,
by y.
that is your answer. Okay,
Yes.
let us see this. These are all equations, you know, these are all equations of conic sections, which we did not do in class 11, section B of class 11. Okay, but we will be coming back to these, but we will get these equations in calculus. That is why I am working out these 3 or 4 sums in the beginning. X square by a square.
Sir, this exercises is important, no?
Yes, this
That are
exercise, implicit
conics.
functions is also important. If you know implicit functions in differentiation, and if you can differentiate implicit functions, you know differentiation. Okay, that
Okay,
means
sir.
you know
Okay,
differentiation.
sir.
Now you do all other differentiation will be easy for you. So now what you do
Yes,
is
sir.
you differentiate both sides with respect to x. Differentiating both sides with respect to x. Y square by b square is d dx 1, which is 0. In fact, we don't write this step. Okay, because it is the beginning, that's why I'm writing. So ddx
Okay, sir.
x square by a square plus ddx y square by b square is equal to 0. That means now 1 by a square is a constant, so you can take it out of the differentiation. 1 by a square ddx x square. See, I can whether I can write in this way. I can write or not
Yes, sir.
equal to 0.
Yes, sir.
So 1 by a square, and what is ddx of x square? It is 2x, right? Plus 1 by b square. What is ddx of y with respect to x? 2y dy dx. Yes, right or wrong?
Yes, sir.
And then I can take two common twice x by a square, x by a square plus y by b square dy dx is equal to 0. That means x by a square plus y by b square dy dx is equal to 0. That means y by b square dy dx is equal to minus x by a square. That means now if you cross multiply, you get, you multiply this b square with this x and you multiply this y with this. So you get dy dx is equal to minus b square x divided by a square y. Clear?
Yes, sir.
Yes, sir.
Let
Yes,
us do
sir.
the let us do the next one. You like white background?
Yes, sir.
Yes, sir.
No problem
Yes,
with
sir.
white background because white is normally
No, sir.
hurting to the eyes. So that's why I never used to use white background. Xy is equal to c square. Differentiating both sides with respect to x, we get ddx xy is equal to ddx c square. Now ddx xy is what? You use u into v rule, right? So x ddx of y plus y ddx of x, and ddx c square, this is equal to 0 because c is a constant. So what are you getting? You get x dy dx plus y is equal to 0. That means x dy dx is equal to minus y. That means dy dx is equal to minus y by x. Clear? Let us do this.
Yes, sir. Yes, sir.
X cube, this type I had shown you that day. X cube plus 8xy plus y cube is equal to 64. So differentiating both sides, with respect to x, get ddx x cube plus 8xy plus y cube is equal to ddx 64. That means ddx of x cube plus d dx of 8xy plus d dx of y cube must be equal to 0 because 64 is a constant. d dx x cube is 3x square. Now 8 I can take out of the differentiation to get 8 d dx of xy. And differentiation of y with respect to x would be, first you differentiate y with respect to y and multiply it by dy.
Yes, sir. 3y.
Okay.
D
Now 3x square plus 8 x d dx of xy is x d dxy plus y d dx x plus 3y square dy dx equal to 0.
I think yes, sir.
Okay, let's see.
Yes.
That means this will be 3x square plus 8 x dy dx plus y plus 3y square dy dx equal to 0. That means we have 3x square plus 8x dy dx multiplying with throughout with 8 plus 8y plus 3y square dy dx is equal to 0. Now I take the dy dx together and all the other terms together. So here you get 3x square plus 8y. These are the other terms apart from dy dx. And what are the dy dx terms? 8x dy dx and 3y square dy dx. Now I can take dy dx common. Okay. I take this to the other side. This. Yes, I have taken this to this side. Yes. Any doubts? Can you hear me? You can hear me or not?
Yes, sir.
Okay. So this
So
this
Govinda
sum is
gone.
it's not there.
No, sir, he's not there.
We'll come back. Let's continue with the other sums. Next sum is little long, but it only looks long. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Need to differentiate this. Okay. Right, differentiating both sides. With respect to x, we get dx ax square 2hxy plus by square plus 2gx 2fy plus c equal to ddx 0, which is 0 obviously. That means ddx of ax square plus ddx of 2hxy plus ddx of dy square ddx 2gx plus ddx 2fy ddx c is equal to 0. A is a constant you can take out of the differentiation. A ddx of x square plus 2h ddx of xy plus b ddx of y square. 2g is a constant you can take out. 2g ddx of x plus 2f ddx of y and ddx of c is 0. So what we get? A ddx of x square is 2x plus 2h ddx of xy is x ddxy plus y ddx x plus b ddx of y square is, first you differentiate with respect to y to get 2y and then you multiply with dy dx plus 2g plus 2f is equal to 0. Okay, so next is that means you get 2ax plus 2h x dy dx plus y plus 2by dy dx plus 2g plus 2f is equal to 0. Now you can take 2 common from the all this. You get twice of ax plus h x dy dx plus y plus by dy dx plus g plus f is equal to 0. I have simply taken 2 common. So that means I get ax plus h x dy dx plus y plus by dy dx plus g plus f is equal to 0. That means ax plus hx dy dx multiplying by h throughout hy plus by dy dx plus g plus f is equal to 0. Now I take the dy dx together and all the others together. So ax plus hy plus g plus f I take together, and I take hx dy dx plus dy dx together, ax plus hy plus g plus f is equal to hx plus by dy dx is equal to 0. So that means I get, this is plus, not equal to. So I get hx dy dx is equal to minus ax plus hy plus g plus f. That means dy dx is equal to minus ax plus hy plus g plus f divided by hx plus dy. So this is my required dy dx. Clear?
Yes, sir.
Yes, sir.
Govinda, you are back. When did you come?
Yes, sir. Yes, sir.
Okay, so let us do the next one. Root x plus root y is equal to root a. Now you will tell me how to differentiate this implicit function. First, let's write differentiating both sides with respect to x.
Plus root y is equal to ds of root a.
Now you tell me the next step.
So first we differentiate root.
I simply distributing the differentiation, doing nothing, and this will be 0. Now you tell me, how will I differentiate root x with respect to x?
Sir, it will be x to the power 3 by 2.
By x to the power of t by 2. I told you to learn up the differentiation of root x.
Yes, sir. Yes, sir. 1 by 2 root x. First
Next,
will be 1 by 2 root x.
how to
Next,
differentiate root y?
Sir, it will be
d dy ds of
You differentiate y with the root y with respect to y to get 1 by 2 root y. And then you multiply with dy dx.
dy dx.
Now it is done. Differentiation is done. Half of 1 by root x. I can take half common from the 2 plus 1 by root y dy dx is equal to 0. That means 1 by root x plus 1 by root y dy dx is equal to 0. That means 1 by root y dy dx is equal to minus 1 by root x. That means dy dx is minus root y by root x, which can also be written as minus root y by x. Clear?
Yes, sir.
Let us do this one. X to the power of let's do this. X to the power of n. X to the power of n plus y to the power of n is equal to e to the power of n. How will you differentiate? I have only 1 minute left. Okay, 3 minutes. I think some can be done in 3 minutes. Let's see. That means ddx of x to the power of n plus ddx y to the power of n. I've forgotten to write ddx here. ddx e to the power of n is 0 because e to the power of n is a constant. What is the ddx of x to the power of n? N x to the power of n minus 1. And how will I differentiate y to the power of n with respect to x? I will first differentiate y to the power of n with respect to y to get ny to the power of n minus 1 and then multiply with dy dx. Okay. Now from these two I can take out n. Which can also be written as okay.
Yes, sir.
That is what dy dx is. Yeah. So I am disconnecting. Okay.